we'll wait for a couple of more minutes for that people can join. Good afternoon. Welcome to the ninth week of problem solving session for the course Availability and Management of Groundwater Resources. I will be dealing with with some sample problems that is related to assignment 9, which will help you do the assignment 9 based on the lecture series that has occurred during the ninth week of this course. So the topics covered is on the ninth week's lectures, which is mainly about estimation of total annual replenishable natural groundwater recharge. We'll move on to the question discussion. So as always, I'll be showing some questions in the slides, and you will require to go to the question and put in your answers in the chat box. And after which we'll move on to the solution. Okay, so the first question is, which of the following is constructed across small streams having gentle slopes? Is it a gully plug? Is it a contour bund, a gabion structure, or are they check dams? Okay, we'll move on to the solution. Now, all these options that are talked about here are some natural methods in which groundwater can be recharged. So let's go through each one of them so that we'll be able to see what the question is about. So gully plug is nothing but it is a structure like this. They are made out of these stones that are available in the locality, and they are placed in such a way in between the across the streams, and it is usually done for small streams and not such heavy flowing streams, so that water will get accumulated over here, and it will naturally recharge the groundwater. So one condition for which these gully plugs are chosen is whenever there is a local break in the slope to permit the accumulation of adequate water behind the bunds. So break in the slope means it will be flowing in at a level, and then there will be sudden change in the variation of that level. It's not going to be a very high steep variation, but when it is flowing at a particular slope and it is then moving on to a different slope, then at such points these gully plugs are generally placed so that water accumulation can happen and naturally it can recharge. So this is also one method to help in prevention of soil erosion. Almost all of these natural groundwater recharge methods are also additionally uh, helping the soil against erosion. The next method that has been discussed is a contour bund. A contour bund is nothing but again bunds which are created in slopy terrains. We must all be knowing about what terrain farming or contour farming is. So similarly, instead of steps, there are bunds created at different slopes, and these slopes will accumulate water. And these bunds will help in accumulating water along the slope and helping in groundwater recharge. And this is also one way that helps in conserving soil moisture for a longer duration, and also it is useful in areas of less rainfall. So I think one important takeaway point is the kind of places that require contour bunting, places with less rainfall, where the water that is being run off from the slopes can be appropriately, otherwise can be conserved in a very effective manner. In case of gully plugs are constructed across streams which are light streams, small streams, which doesn't have very huge. Then the next structure is a gabion structure. A gabion structure is nothing but again along the banks of some rivers. The boulders and rocks are together filled inside meshes, and then they are placed at the banks of the river. So what happens is when the water starts flowing in excess out of these rivers, it will go into these in between these boulders, and it will help in recharging the soil. So these are called gabion structures. Then there are check dams. Check dams are again small streams having gentle slope. That is, it's not the slopes are not very steep, but then it is flowing across a slope, flowing along a slope. So check dams are small dam-like structures, concrete structures, so earthen structures that is constructed across these streams, and it will help in blocking water. And then when the level of the water increases, there is a provision for overflow of water, or there are sometimes sluice gates that are made just like how it is made in big dams for allowing the water to flow. So this is also one method of naturally recharging groundwater. So here again, these are constructed across small streams having gentle slopes. So gully plugs along light streams where there's a break in the slope of the stream. Then contour bunds along steep terrain where generally the rainfall is low and the runoff can be impounded using these contour bunds. Gabion structures again along the banks of rivers, and check dams are for gentle small streams with gentle slopes. Again, another two methods discussed over here is a subsurface dike or a groundwater dam. So similarly, how the dams are constructed across the rivers for impounding water, there are structures like these barrier-like structures that will impound the groundwater itself, and then that is also one method of naturally recharging the groundwater. Then dug well recharge is nothing but old dug wells are filled with water, and the water is allowed to recharge the surrounding stratum. So these are some methods in which groundwater is recharged naturally. So our question was, which of the following is constructed across small streams having gentle slope? So we checked just the check dams which are built across streams with gentle slope, gully plugs along streams which has a breakthrough slope, contour burns in regions of low rainfall, and gabion structures are those structures with boulders put in mesh. So that was the first question. Moving on to the second question. An unconfined aquifer having water at 103.2 meters below the ground level at the start of a month. In that month, it is receiving 150 mm of water through infiltration and a water depth equal to 70 mm was extracted. What will be the water level at the end of the month? A pretty straightforward question. They're asking for the water level at the end of the month. They've given us the water level at the starting of the month, and they have also given us how much of water is being filled into it and how much of water is being removed from it. We just have to make use of the water budget equation and find out what is the water level at the end of the month. Okay, so let's move on to the solution. So the water budget equation is this. The total inflow minus the total outflow will give us a change in storage. So here they're asking is what is the water level at the end of the month, and we have the information about the initial water level, the amount of happening, amount of discharge that is happening. So the net inflow here is given as 150 mm of water is getting into the soil through infiltration, and a net outflow is given as 70 mm. So if you just simply minus 150 minus 70, you're getting 80 mm of water is being stored in that aquifer or soil medium. So initially 103.2 meters of water was there. So adding to it, if you add this 80 mm of water after converting it to meters, because we have the water level in meters. Um, wait. I think I'll come back to this question, because I have a doubt if it is adding the water level or removing the water level. If the value is positive, you're supposed to be adding that value, but here it is given 103.2. It is subtracting the value, which I'm not very sure of is the correct answer. I'll just verify with this and come back to you. We'll come back to this question once again. Moving on to the next question. Which is the correct equation to calculate groundwater recharge by infiltration factor method? Hello. Okay, so which is the correct equation to calculate groundwater recharge by infiltration factor method? Okay, moving on to the solution. So the method that is being discussed in this question is about the estimation of the groundwater recharge. How much of water is being recharged into the groundwater is what is this rainfall infiltration factor method used for, and using this equation we can find out how much of water is recharged in this method. The formula is as shown here, F into A into normal rainfall in monsoon season, where F is the rainfall infiltration factor, A is the area for which the recharge is being computed, and normal rainfall in monsoon season. We had discussed about what normal rainfall was in the last session. It's the annual rainfall that is taken for 35 years, and that rainfall in that for a particular year or particular season is compared with a normal rainfall. So this is one method of computing the groundwater recharge. So the correct answer for this question would be F into A into normal rainfall in monsoon season. This is option A. Moving on, fluctuation in the water table is expressed by which of the following expression? How will the fluctuation in the water table be expressed? Is it by finding out the average of the water table in the post-monsoon and pre-monsoon season, or seeing the difference of water level between the two seasons, or adding the water levels of both the seasons, or again finding the difference and then dividing it by two? Okay, moving on. So fluctuations in the water table are majorly caused because of the change in the water level as a result of the precipitation that is occurring during monsoon, and how that water during the post monsoon period, how much water will go up. So the apt period to check the water level is before the monsoon happens and after the monsoon happens, because during monsoon season there will be accumulation of water in at different ways. So it is not a appropriate time for measuring the water level. So pre-monsoon and post-monsoon periods are the appropriate times for checking the water levels. Now, fluctuation in the water table can be measured by uh, uh, checking the level of the water table in the post-monsoon season minus the water table in the pre-monsoon season. So post-monsoon will definitely generally will have higher water table, because after monsoon the water level is will as common sense explains it, water level is going to increase. Now, pre-monsoon season, it is the end of the month. It is just the time before the monsoon, so the water levels are going to be less. So from that, we'll be able to understand how much of water accumulation has happened. It is usually measured in meter below ground level. So the correct answer for this would be water table in post-monsoon minus water table in pre-monsoon season. Moving on to the next question. As per the assessment of Ministry of Jal Shakti that happened in 2017, what is the total amount of annual groundwater recharge that is occurring in our country? Yes. So according to the assessment that the groundwater assessment in 2017, firstly the Central Groundwater Board along with the state governments, boards and state governments are the bodies that are keeping an assessment of these countries changing groundwater resources. So there was an assessment that happened in 2017, and according to that, there is a total annual groundwater recharge of 432 billion cubic meters, and out of that, 393 billion cubic meters can be extracted. Now, out of the extractable 393 billion cubic meters, what is being used in a country is 249 billion cubic meters, out of which 89% is used for irrigation and only 25% is used for domestic purposes. So, we have, according to this assessment, we have 432 BCM of groundwater, rechargeable groundwater available, and 393 BCM that is extractable. So the answer for this is option B, 432 billion cubic meters. Moving on to the next question. Confined aquifers are not directly recharged by vertical infiltration. Is this statement true or false? Okay. So, unconfined aquifers are the aquifers that are recharged from rainfall. So, it is like, it's not confined by any layers. So, whatever rain is falling onto the ground surface, the infiltration will occur and the water will reach, as it travels down, it is going to reach the water table, which is nothing but the unconfined aquifers. Whereas in confined aquifers, these aquifers are generally recharged as a result of this confined aquifers is going to be unconfined at some point in a very long distance away. The end of this confined aquifer would be an unconfined aquifer, and only when this unconfined aquifer, which is at the end of this confined aquifer, is recharged, that water will flow and flow and flow and come, and it will recharge the confined aquifer. Now, the movement of groundwater is very slow, so recharging of confined aquifers takes around centuries, and you can see here as the number of stratum or layers as it goes deeper and deeper, the recharging time for this confined aquifers are going to not just take centuries, but going to take more than 1,000 years. So it is why the groundwater is a very important resource. Depletion of groundwater has to be taken very seriously because when waters from unconfined aquifer is not available, people are drilling wells into confined aquifers, which takes a long time for recharging. So that is why this is a very critical thing to be taken into consideration when it comes to conservation of water resources, particularly groundwater. So vertical infiltration only recharges unconfined aquifers. It doesn't recharge confined aquifers. So the statement they're not directly recharged by vertical infiltration is true. It's a simple numerical. A small aquifer having an area of 150 hectares is receiving 100 mm of water through infiltration over a span of 1 day. The water is drained at the rate of 1.5 meter cube per second during that time. Find the change in storage. This can be found using the water budget equation. So the area is provided. What is the recharge? How much of water is inflowing into it is being said as 100 mm of water. The time during which this inflow is happening is the duration is being given. Outflow rates also been given. We need to find out what is the change in storage in mm. So the units are something that we need to important to be considered um, here. Okay. So the water budget equation, you can see here is the inflow minus outflow is equal to change in storage. We know inflow is when we're talking about inflow, it's a net inflow, and outflow is a net outflow. Change in storage is given by deltas. So here inflow is given as 100 mm. Area is given as 150 hectares. So when we convert this 150 hectares into meter square, 1 hectare is equal to 10 to the power 4 meter square. So 150 into 10,000 will give 150, 1,500,000 meter square, or you can say 15 lakh meter square. Now outflow they have given in terms of rate. Here inflow, if they given the inflow in terms of millimeter depth, outflow they have given in terms of rate. So it is we need to find the change in storage in mm. So we need to convert the outflow rate into outflow depth. So in order to do that, we calculate the outflow volume by multiplying this term with the duration at which the outflow has happened. They have said that it is getting recharged by 100 over a span of 1 day, and also outflow is also happening during the time. So 1 day is the duration we have here. So we'll multiply the 1 days and convert it to, by converting it into second, we'll have to multiply with 24 into 3600, giving us this number 129,600 meter cubes. So from here we got the outflow volume. Now, in order to calculate the millimeter depth, we have also been given the area. So we will divide this 129600 by this area of meter square we have got. So meter cube by meter square will give meters, which is equal to 0.0686 per meters. Converting this to millimeters, we get 86.4 millimeter. Then using this equation, inflow 100 minus outflow 86.4 is 13.6 So the correct answer is option A. There will be a water level. Water level is going to rise by 13.6 So this is exactly what will happen in the second question that we had discussed. The second question over here, instead of this value, the final level, the water is going to rise by 0.08 So it is going to be plus 0.08, which is going to give 103.28 meters. So the options provided here are wrong, but the solution is the solution is right over here. So when I publish the slides, I will publish it accordingly. But the solution that you need to follow is this. So please refer to the published slides when if you're seeing this video, and use them for doing this problem. Okay. So that was this question. Moving on to the eighth question. India is receiving rainfall from both the months, which both monsoon seasons? Okay. So the correct answer is option A. So India has got two types of monsoon season, the southwest monsoon and the northeast monsoon. The southwest monsoon is the major type of monsoon, which gives us 75% of the rainfall. Northeast monsoon, some parts of the country get major rainfalls from the northeast monsoon. So India receives rainfall from both of these seasons. So major two seasons, monsoon seasons are the southwest monsoon and the northeast monsoon. Next, in India condition, which of the following months is considered to be pre-monsoon period? So we have talked about when we'll check the water level situations. It is the difference between the water levels in the post-monsoon season minus the pre-monsoon season water level. So what period is this pre-monsoon period is the question over here. Is it from September to October, April to May, August to September, or January to February? The pre-monsoon period will generally mean it's a summer time. So we can think about when it is summer and then answer the question accordingly. Okay, let's move on to solution then. So according to the IMD, Indian Meteorological Department, we have four major seasons: summer, southwest monsoon, winter, and northeast monsoon period. So that monsoon is considered as the post-monsoon period or the autumn season. So winter is occurring. Let's start from the summer period. So summer or pre-monsoon season is lasting from March to May. So from the period of March to May, it is really hot and it is called the summer season. The monsoon season is lasting from June to September. Then the post monsoon is from October to November, and the winter season is from December to February. So starting summer from March to May, June to September is the southwest monsoon. Then post monsoon, which is from October to November, is called the northeast monsoons. And then from December to February, we have winter. So here the question was, when is the pre-monsoon period? There is no option giving us March to May, but then April to May is there. So the correct answer here is option B, April to May. So June, July, August, September is the monsoon period. October, November is the post-monsoon period. December, January, February is the winter period. Question number 10, which of the following is not a method to estimate the groundwater recharge? So there are some methods of groundwater recharges that you learning through these lecture series in the 9th week. So which out of this following is not a method of groundwater recharge? Okay. So we are talking about the methods to estimate groundwater recharge. We had looked at one method earlier, which is the rainfall infiltration method. So another method is the groundwater level fluctuation method. So in this method, recharge from the fluctuation in water table is considered, and the recharge is estimated as a function of the specific yield, the change in storage or the change in the water level, abstractions during rainfall, and return flow. So these all these factors are being considered to in this method of computing the recharge of groundwater by understanding the fluctuations in the water table. So specifically, we know the change in storage. The abstractions means water that is being extracted during the rainy season. That is what they mean by abstractions during the rainy season. And return flow, as they have mentioned here, is when there's any irrigation which is occurring during rainy season, that will be considered under return flow. So this is one method of computing the computing the recharge of groundwater. Now groundwater balance is again the water budget equation where they're considering the inflow of groundwater minus the net outflow of groundwater for a particular duration, and W will be the change in the volume. Change in volume by change in time is going to give change in storage. So like we did the problems, if it is given in depth, we have to the rate has to be converted into depth using the area and the duration of the flow that is occurring, and obtain it in terms of depth. Then the rainfall infiltration factor method, we saw this during some initial questions. Multiplication of the rainfall infiltration factor, area, and the concentration of the normal rainfall. So out of all these methods, it's just Thiesen's polygon method, which is not used for groundwater recharge. Thiesen's polygon method, we had checked in the last session. It is a method to estimate the mean rainfall. Okay, moving on to the 11th question. Calculate the value of the recharge using the groundwater level fluctuation method by using the data given. Here, the specific yield is given, effective change in water level is given, and return flow due to irrigation is said to be negligible. So it means we can take it as 0. Compute what is the recharge value. So just to remind you, the formula is Sy into delta S plus Tp into Rt. Tp is abstraction, Rt is the return flow, Sy is the specific yield, and delta S is the change in water level. Okay, so let's look at the solution. So here the specific yield value is given, delta S value is given. Tp, talk nothing about Tp. Rt value is said to be negligible. So when you take Rt value is equal to 0, Tp into Rt is going to be 0. So this entire term will be equal to 0. Then recharge can be calculated just as a product of Sy and delta S, and Sy is equal to 0.09. So 0.09 into 50 is the change in water level. Whole thing will give 4.5 centimeters. So the correct answer is 4.5 centimeters. Once again, this is the formula for calculating the recharge. That is product of the specific yield and the change in water level plus return flow into product of return flow into abstraction during rainfall. Rt is said to be 0, so the product of this will definitely be equal to 0. So then by multiplying the product or finding out the product of the specific yield, which is given as 0.09, and delta S, which is given as 50 centimeters, we will get the recharge is 4.5 centimeters. So 4.5 centimeters of water is being recharged. So the water level is going to increase or raise by 4.5 centimeters. Okay, moving on to the next question. Which out of the following is considered as a groundwater year in India? Okay. So groundwater here is nothing but just like how we have to do the like considering the water year, which is from May 31st to uh, June 1st to May 31st. Similarly, for the estimation of groundwater also a period has to be a standard period has to be considered, and that is 12 calendar years beginning with the commencement of the predominant monsoon. So in our country, we know that the predominant monsoon is generally southwest monsoon. But say if it is northeast monsoon, then 12 calendar months starting from the predominant monsoon will be the excuse me, groundwater year in India. So the option A will be the right answer. It is 12 calendar months beginning with the commencement of the the predominant monsoon season. That is going to be the groundwater year. So it is not starting from January till December, but it is starting from that most dominant monsoon in that year and 12 months from that. Now, what does a groundwater assessment year mean? Again, these are some basic terms that is taken into consideration during the assessment of groundwater. What a groundwater year, a groundwater assessment year, groundwater assessment units. Again, there are sub units. So there are a lot of terms that is taken into consideration, which are all available in the lecture series. Okay. So a groundwater assessment year is nothing but when the assessment is made that year. If the assessment is made for a particular year, then that year is called the groundwater year. So a lot of terms are available in the lecture series regarding this groundwater assessment. What is a year? What is an assessment unit? What are sub units? So it would be helpful to go through that. Now, what type of recharge method is involving using boulders and steel meshes? So we learned about few methods of groundwater recharge that occurs naturally, that can be done naturally. So we had also discussed about the conditions during such methods are used. So out of the four, which of the method is linked to use of boulders and steel meshes is the question. Okay, so it is the gabion structure. You can see here gabion structures are constructed along the banks of rivers by collecting all of the rocks and boulders that are present in the vicinity and putting it into steel meshes. So what happens is when the water starts flowing in excess, all the water will start flowing into these structures and it will recharge the groundwater in that way. Store the water and then recharge for So the correct answer for this question is option D, Gabriel structure. Okay, so now we'll discuss some questions that I thought would require some discussions. for assignment 7. So here a small catchment area is receiving a total rainfall of 150 mm during a storm. The initial recharge is 50 mm. Groundwater accretion is 20 mm. What is the surface runoff generated by the storm? Okay. So here they have given that the total rainfall occurring is 150 mm. Initially, the basin recharge occurring is 50 mm. And groundwater accretion, which is again addition of groundwater, which is 20 mm. We have been asked to calculate the surface runoff. So we can make use of the equation. The runoff is equal to inflow minus the outflow, which is P is the 150 meter, 150 mm rainfall. L is the basin recharge 50 mm. 20 mm is the groundwater excess. So 150 minus 70 will give you 80 mm. So the surface runoff that is generated by the storm is 80 mm. So here we have been asked to find out the runoff that is generated by the storm, and water that is coming in is 150 mm, and apart from that, recharge is also there, and groundwater level is also there. So the total inflow minus the outflow will give you the runoff. Okay. Now some questions that require discussion in assignment 8. What type of rain gauge is providing a continuous plot of rainfall against time? Here, what I found a little bit confusing is the options B and C, and D, which is technically tipping bucket and weighing bucket, both are recording types. But again, since all the recording type of rainfalls provide a continuous plot against rainfall, we can say the option B is the correct answer, which is recording gauge. So all of them give a continuous plot. Um, so hence option B would be a correct answer. Then which equation is used to calculate the infiltration capacity using soil moisture and vegetation cover? All of these four equations are equations that are used for finding out the infiltration, estimating the infiltration. Out of this Horton method, the value K, which is a constant that depends on the soil type and vegetation cover, is also used in finding out the infiltration capacity for a particular duration. So that is why the answer for this question would be Horton's equation. So it is important that you check out what all the equations are, what is the formula, as well as what is the terms and variables in the equation mean, and what are the units of it. Again, in this question, what does the W index represent in terms of infiltration? Uh, the Okay, W index represent in terms of infiltration. There's some miss. The slide is not properly made, so I'll correct it and then publish it. So here we are talking about phi index and W index. Phi index and W index are nothing but they are infiltration indices that are used for estimating the water loss which is occurring as a result of infiltration. So according to this phi index, what they say is, if you see here, what is given as a rainfall hyetograph. So in a rainfall hyetograph, it is nothing but the plot of rainfall intensity versus time. So a line you can see is drawn here. So according to this phi index, this value of the rainfall intensity is called the phi index. So all of the rainfall that is occurring above this is considered as runoff, and all of it that is occurring below is considered as water that is water that is gone as a result of infiltration. So if you need to consider what is the amount of infiltration, if you have the phi index and the hydrograph rainfall value, the duration, etc., we will be able to understand how much of water is going as a loss. Water is lost as a result of infiltration, and how much is going off as surface runoff. It is for this purpose that phi index and W index is used. Phi index is the difference between phi index and W index is nothing but phi index is only considering loss due to infiltration. We are not considering losses due to interception or depression storage, whereas W index will consider the loss due to interception and depression storage as well. So here if the equation for phi index is P minus R by T, S is not being considered. Whereas for W index, it is P minus R minus S by T, where S is the term taking care of the depression storage and the interception losses, and R is the runoff loss, and P is the total runoff. W index is giving us the average rate of infiltration. So W index is more accurate than phi index because they're considering this interception and this depression losses also. Now there was this question which didn't make much sense to me, so I was wondering if you would also be able to give an input into this question. So if anybody has any idea, I mean, I understand precipitation, water droplets are coming together to form larger drops, but the size of this is not something that makes sense to me. So I was wondering if I would get some input on this. Then there is another question used for calculating the rate of rainfall for successive 30-minute period of 4-hour storms. They have given the rainfall values in terms of centimeter per hour and also the phi index value. And they have asked you to find the total rainfall. So in order to do this, what you have to do is add all of the rainfall values, which is given in terms of the intensity, and then convert it to centimeter, because the answer here is in centimeters. It is necessary you convert it to centimeters. Here the intensity of rainfall is given, not the depth of rainfall. So for converting it into depth of rainfall, you will find the sum of this intensity and multiply it with the duration. So here they have given it is occurring at successive intervals of 30 minutes. That is, every half an hour is 3.5 centimeters of rainfall will occur at for half an hour. After that, 6.5 centimeters will occur. You don't have to worry about this 4-hour storm. 4-hour storm is nothing but it is how you classify the rainfall. There is a different meaning for it, but for now you can just understand that it is a storm that is it is a 4-hour storm, but the occurrence of rainfall is at a 30-minute interval, and so we will multiply half an hour with all these values to find out the depth of the rainfall. Now the same problem they can also ask us to find out the runoff. So in order to find out the runoff, we make use of the phi index W index equation. Okay, since they're not asking us, they're given the phi index, we'll make use of the phi index equation. So phi index is equal to P minus R by T. We know P is equal to 23.35 centimeters. We are supposed to find R. So phi index they have said is 4.5 centimeter per hour. Phi index is nothing but the average infiltration rate. So it's a rate value. It is going to be in centimeters per hour. Now time here is, it is the total time is what is being talked about when you say talk about the value, or when you see this value T, it is a total time. So total time is 8 episodes of rainfall is occurring every half an hour. So 8 into 0.5, 4 hours of total storm is occurring. Now 8 into 0.5 will be the total time that is total time over here. So bringing the terms in the left hand side and right hand side accordingly, you will find out that 4.5 into 4, 23.5 minus 4.5 into 4 will give you 5.5 centimeters. So that is going to be the runoff that is occurring. So this is how the problems will come when it comes to pi index as well as in W index. So that's all for today. If there's any doubt regarding the session, you can ask. Otherwise, you're free to leave the session. For those of you who want to do the problems continuously, you can always attend the last time of my problem solving session. I'll be auto playing the slides for every 10 seconds, so you can make use of that to do the problems on your own and checking the answers. So that will be for today's session. I will be here for a couple of more minutes. There is some discussion need to be done. Otherwise, if we to leave the session, thank you for attending.